If I told you there's a machine on Earth that makes a tiny artificial sun, would you believe me? China's East reactor does exactly that, by smashing atoms together until they fuse, the same way the sun powers our solar system. Here's the wow. Inside East, the plasma, the superhot soup of charged particles, can reach 120 million degrees Celsius. That's almost 8 times hotter than the sun's core. East has held that blazing state for over 1,000 seconds, more than 16 minutes, at around 70 million degrees. Why does that matter? Because fusion needs extreme heat and pressure. Light atoms, like hydrogen's heavy cousins, deuterium and tritium, overcome their repulsion and fuse into helium, releasing a burst of energy. The trick is holding fire that hot without touching anything. East uses a tokamak, a donut-shaped vacuum chamber wrapped in powerful superconducting magnets. Those magnets, over 100,000 times stronger than Earth's magnetic field, levitate the plasma in midair, shaping it into a glowing ring that never touches the walls. When deuterium and tritium fuse, each reaction releases about 17.6 MeV of energy, tiny per reaction, enormous when you have trillions per second. A palmful of fusion fuel could match the energy of tons of coal, without smoke, soot, or carbon emissions. So why isn't your house already powered by a star in a jar? 3 big challenges: net energy, materials, and continuous operation. Net energy means more power out than in. East is a physics test bed, not a power plant. It's built to understand and control plasma, to learn the recipes for stable, high-performance confinement. Materials must survive a storm of high-energy neutrons without getting brittle. And we need to run not for minutes, but for months, reliably, safely, and economically. East is pushing all 3. Advanced magnetic control, superconducting coils chilled near absolute zero, and real-time plasma feedback that keeps instability at bay. Scientists watch rivers of data in control rooms as the plasma dances, taming turbulence, squeezing more performance from every second. Scale this up, and you get the dream. A handful of fuel from seawater and lithium that could power a person's lifetime. Imagine futuristic power grids lit by fusion plants, clean baseload energy humming beneath cities, backing up wind and solar with star power on demand. No smokestacks, no long-lived high-level waste. Just heat turned into electricity with helium, the same stuff in party balloons, as the main byproduct. It's not magic. It's engineering, iteration, and a lot of patience. East is one of the world's key stepping stones, proving we can control a miniature sun long enough to make fusion practical. When we crack net energy at scale, we don't just power homes, we power possibility. Thank you for watching. Stay curious and keep exploring the world of invention and discovery. Don't forget to like and subscribe for more discoveries on Invention Chronicles. You're watching Invention Chronicles, exploring the greatest ideas ever imagined.